672, 672. 755, East 80th Street. 755, East 80th Street. Tiffany Miles, that mailbox is falling. He's got to touch the heavy set where it got closed. Stays hiding.
Friday, January 8th, 2016. The time is 1:17 p.m. This is Dr. Ray. I just arrived at the crime scene. The murder weapon is a knife. There's a pool of blood on the floor and an outline where the victim was found. I'll collect a sample of the blood. Friday, January 8th, 2016. The time is 6:32 p.m. I've just arrived at the lab. I'm going to perform gel electrophoresis on the blood sample that I collected earlier. The hope is that it will help us identify the killer. Here I have 2 grams of agarose gel measured out. I will now pour it into the electrophoresis buffer. Now I'll microwave the solution in order to get the agarose powder to dissolve quicker. Now I'll pour the solution into the machine. Here are our blood samples. I've put them into test tubes with some enzymes to cut up the DNA into small segments. Before we begin, we must first understand what DNA is.
Deoxyribonucleic acid, or DNA, is the molecule that makes up the genetic information in our bodies. DNA is unique to everyone, therefore we can use it to ID our killer. DNA is made up of nitrogen base pairs: adenine, thymine, guanine, and cytosine. Adenine pairs with thymine, and guanine pairs with cytosine.
The enzymes will cut the DNA whenever a particular pattern of base pairs appear. This results in segments of DNA of varying lengths. I will now turn on the machine to apply an electric current to the DNA. The negatively charged molecules will be naturally attracted to the positive end of the machine. When we put them in the machine, they move through the gel at different speeds because the long strands are heavier and the short strands are lighter. I've added dye to the DNA so that we can see it clearly under the UV light. It's a perfect match. We did it! We caught the killer. Case closed.